Hello and welcome to another video in our PCB design skills series. In this video, I'm going to be taking you through the process of understanding a manufacturer's design capabilities and how that can be then taken into KiCad as design constraints, which allows you to make sure that you're designing your board to the physical capabilities of the manufacturer you're using, much like we did for the milling machine, and then also allows you to run the design rules checker and make sure you haven't missed anything in terms of what the manufacturer is physically capable of. Then we're going to time skip a little bit and have a look at a finished board and how we can take that finished board into JLC's website and just visually inspect that all of the layers we want are actually there, everything looks legitimate, and that we're happy and ready for it to go and be sent to manufacturing. So as I've mentioned, this video will focus on JLC because they're the manufacturer that we're using in this subject, but the principles that we'll go through really do apply to other manufacturers as well. So if you're doing personal projects or whatever else, this same kind of pipeline will be similar across different manufacturers too. So to start off, first thing I'm going to do is I'm going to Google JLC's design rules. So manufacturer, design rules, design capabilities, whatever you want to call it. And you should find something like this link here. So JLC's PCB manufacturing and assembly capabilities. If we go into here, then we can see that they've got three different sort of options to pick from: rigid PCB, flexible PCB, or a full PCB assembly. In this case, we're only interested in rigid PCB, which is your standard flat, hard-bodied PCB that you would normally see. Then you can dig into the different specifications that JLC have. So they allow 1 to 32 layers, for example. And there's some information about materials and stuff like that. But most of what's interesting to us is things like the drilling capabilities and the traces. So the drilling tells us things like how wide can our holes be at a minimum. You might still choose to make them wider, that's fine, but that's the minimums that they have there. Same thing with things like our vias, which connect sort of the two or more layers together. Spacings, a few things like that there. Same with traces, it gives us things like what's the absolute thinnest our tracks can be, how far apart do they need to be, so on and so forth. So all of this, there's a lot of information here, right? It would take a fair bit of work to work through all of this and find all of the things that actually matter to you. So what we've done is we've actually done that work for you. So we've made this document where we've mapped together the JLC capabilities with what the constraint is called in KiCad. So that means instead of having to read through all of this website, you can have a look at this here, see what it would actually be called in KiCad. We've given you the values and a little bit more of a description for a lot of them so that you can get a better understanding of what these things are actually constraining. So given that we have done this interim step for you, all you need to do is head over into KiCad and actually add those as constraints. So before we go to the board, I'm just going to briefly show you the circuit that we're working with. So we're using that same rectifier circuit from an earlier video. But in this video, I'm going to quickly redesign it for JLC's constraints because it'll actually allow us a lot more flexibility than the milling machine did. And then, yeah, I'll go through the process of exporting that and everything else. So when we open up our PCB editor here, you can see it's totally blank. I haven't designed anything yet at all, and I'll be adding that after I set my constraints. So your first step as soon as you open this is to set up your constraints so that everything you do is actually in line with those constraints. So head on into the board setup tab. So that's your little green PCB with this little gear in front of it, and head down to the design rules tab and the constraints sub tab. And it's just a case of now working through this document that we've given you. So the minimum clearance was 0.1, minimum track width was 0.1, minimum connection width was 0.1. And you can see those are all small numbers, right? Like you don't necessarily need to have things that small. In fact, I'd encourage you to go slightly bigger with your track width, but that's the absolute thinnest that JLC could possibly support. So then we've got our annular width, we've got our via diameter, our copper to hole clearance, copper to edge clearance to make sure nothing gets chopped off when we do our edge cuts, through hole 0.3, hole to hole spacing is 0.45. Micro via diameter and hole, so these are like really small vias that provide connection between multiple layers, but JLC doesn't actually support that. So you can pretty much just leave that as it is because you're not going to be able to do micro vias anyway. And then the last couple parameters about text are to do with the silk screen. So any annotations that we're going to put on top to label our components, put our name on, etc. That's what's being controlled here. So 0.16 was our clearance between items. That wasn't actually a specific JLC constraint. It was sort of linked to a couple of them. So just trust me, essentially. And then 0.16 for our text thickness. So that's all of them. The only other thing to note that I've included in this document is the size constraint for your overall board. Absolute maximum for JLC is 100 by 100 mil. You won't need anywhere near that much. So I'm constraining you to 50 by 50. And in fact, you shouldn't need anywhere near that much either. So again, as with the PRAC, the smaller the better. Good design is a big part of what you're trying to achieve with your PCB. So that's our constraints done, everything's filled, we can click OK. The other thing that we might like to set up here is it's useful to set up a predefined track size. So if you click on this drop down on tracks, you can edit the predefined sizes and you can actually create an existing size for the tracks. And you would want that to be at least as much as the design constraint. But like I said, you might want to go a little bit bigger as well. So we could go 0.2 millimeters for our track width, and that would be a reasonable choice. Same with our wires. We might want to go a bit bigger with our wires than we technically had to. So when we hit OK, this is the point where we might want to add our components in. So update from our schematic. And it'll think for a little bit. And there's all our components. So then we would be able to lay them out and start wiring them. Now, you've seen me do this before, so I'll pause the recording here, imagine some fast forwarding going on, and I'll come back with a finished design. All right, and then we're back sometime later with our cute little PCB that's now ready to actually export and take over to JLC to check out how it looks manufactured. Before we do that, we probably want to also have a look at how it looks on the 3D design view. So a few things that are different about this board compared to the first time we did it for the milling machine. I've routed everything on the bottom again, but I've actually made my ground plane the entire top layer. So no traces at all on the top layer, just ground plane, which is really, really good for signal integrity. And then we also have some silk screening done. So all of the actual yellow stuff that you can see, if I turn off my red copper, that's all actually going to be part of our printed design now. So let's take a look at that 3D view. And you can see that that's what it would look like all assembled. You can see the text that I've added in is there. All of this top will be that copper ground plane. And on the bottom, you can see that there's those thin little traces routing together the components that need to be routed together. You can also have a look at what it looks like without the components soldered in. So you can turn off those models and you can just have a look at whether the silk screen looks nice and neat and you're happy with all of that aspect as well. Then when you're satisfied and also that you've checked that it passes all of the design rules, which I did already do, but now you can see that I've done it and you can believe me. So now that we're happy, we can go and export it. So head into our fabrication outputs and grab our gerbers. Make sure all of our stuff's unselected here, and make sure you're including all the layers that you want. So we want to actually have the copper layers front and back because I've used both of them in this case. We also want the paste, the silk screen, the mask, the edge cuts, everything that's selected on by default here, we want. Pick a folder if you don't have a folder already. So I'll create a new folder for fabrication files here. Cool. Select that folder. Yes. Then plot that and generate our drill files in the same spot. And when that's all done, we would have that available for us to have a look at. So if we go over into here, look at that, I already had the right folder open and all. We can see that all those Gerber files there are there, as well as our drill files. So much like with the milling machine, these are the things that we need to be able to then send it away to manufacture. So then once you've checked that you've got all your fab files there and you're happy with that, then you want to actually go and put it into a zip folder because that's what you'll need to upload it to JLC as. So I'll do that. What I'm also going to do is I'm going to just create a copy of this, and I'm going to like intentionally make some errors. So the reason I'm going to do this is so that you can see what it would look like if I stuffed something up. And in this case, what I'm going to stuff up as a nice little demo is I'm going to not do the drill files. So I forgot to export my drill files, let's imagine. So I'm also going to create that one as a zip file to show you. All right, so then once you've got your zip folder done, you want to head over to JLC's website. You will need to create an account. I'm already logged into mine, so you can see that there. Otherwise, you'd have like a sign in, create account button there. Once you're all set up, go into order now as if you were going to start a new order. And the first thing you can do straight off the bat is add your zip folder. So let's start with the one that has errors. So if I attach the zip folder one, it'll think for a little bit. All right, so you can see here that there's plenty of pads, but there's no holes in the pads. So you can click on this Gerber viewer here, and you can get a closer look at that 2D layer, 2D view. And you can see all the pads are there, but there's no actual holes punched through them. We can do a 3D view, see that the same thing is true on the other side, surprise, surprise. And we can also inspect the layers that are included. So we can check that we've actually got our solder mask there. We've got our silk screen there, top layer, bottom layer. But again, there's no drills. So that one is an error. We would want to get rid of that and start again. So go back to our upload file. In your case, you'd probably be re-exporting it because your errors will probably be accidental instead of intentional. But I already have the correct one, so I'll pop that one into here now. So this is the error-free version of my board. All right, sometime later we actually have an uploaded file. So you can see now that I've given it the full files with the drill, we've actually got the holes in place. So where before it was just bronze here, now, well, copper, I guess. Now we can actually see that there's holes in that copper there. So again, we can go through that same process, and I encourage you to, of going to the Gerber viewer and have a look at the 3D predominantly, so you can see what it looks like top and back. Very similar kind of to what you would do in KiCad. You can also inspect that each of the layers are the layers that they're supposed to be. So you've actually got your bottom layer, top layer, your drill files there as well. Yeah. Cool. All right, so that now looks pretty believable. So what you would be doing is you'd be including some screenshots to send to the techs of the front and the back so that they can kind of believe that you've got everything ready to go, and they can more easily identify if you've not gotten it all right. Cool. So that is it for your quick skills video on how to get your board JLC ready. Hopefully you found this helpful in preparing your board for the assignment. Make sure you also watch the video on more advanced PCB design skills. I think I've called it leveling up your PCB design or something. So that goes through some of the skills that I've actually shown here, like using an entire layer as a ground plane and also things like 2-layer routing. So make sure you watch that one as well. But for now, this is this video done, so I'll see you later.